So as I said, we're going to be speaking about interpreting graphs. And the first step of interpreting a graph is knowing how to find the coordinates. Okay, so we're going to do this quickly, remind each other and ourselves how to find coordinates of points. And we're going to start off with A. What is the coordinates of point A? Let's hear. Remember coordinates, you write your x value first and your y value, and it depends on whether the point has moved or not. Okay, our point of origin is always this over here. So you look, has it moved left or right? Has it moved up or down? Okay, let's get going. Let's look at A. So for A, it hasn't moved left or right at all, which would make my x coordinates is 0, but it has moved up once, which means my y coordinate is 1. Nice, guys, we're off to a great start. Okay, let's look at B. Can I have the coordinates of B, please? My handwriting is still warming up to being back, so just forgive it for today. Let's see the coordinates of B, guys. 1, 0, which is correct because this time we moved right to, I almost said to the 1. We moved to the right 1 unit and we haven't moved up or down. So my y coordinates is then A0. Great. Let's move on to C. Let's see what we have for C. See what I did there? C is over here, guys. The blue guy. We have moved right how many times and up how many times? That is correct, Alice. We started off here and we moved 1, 2, 3, 4, 5 to be in line with the point C, and we've moved up once. Great. Let's see for D. Called point D, which is over there. Maybe I should zoom out a bit. Maybe we are hard at, yeah, English just ran away after I started my sentence. Nice, Senyani, Alice. We've moved to the left 1, 2, 3 times. So that is a -3. And down 1, so that's -1. Perfect. Let's go to E. Is someone hands up? Someone's hand is up. I just can't see who. Okay. That's correct. My E x coordinate will be 4 because we've moved 4 units to the right, and down -3 times. And finally F, which is all the way up there on the top left. Coordinate for F is -3 and 6. Let's check. 1, 2, 3. Yes, we have a -3, and we've indeed moved up 6 points. Great. So our brains are still functional. Okay, well, your brains are still functional. Mine is still getting there, but yours is still functional, which is wonderful. Okay, now let's look at the 2 types of graphs. We've spoken about these before, but I thought I would include a formal definition over here. Okay, the first things first is we need to know what a linear graph is. Okay, so linear graphs are graphs with a constant difference between the terms. Okay, and that will result in a straight line graph. Now that constant difference has to be between all the terms. You'll see why I'm emphasizing this later on when we're doing exercises. Okay, so this is a constant difference between all the terms, not just 2 or 3 of them, all of them. All right, so this is what a linear graph would look like. It is an absolute straight line. If I put my ruler at the first and last point, the whole graph will fall along the ruler. That's basically what we mean. Okay, and for a non-linear graph, you do not have a constant difference. You have a difference, but it's not constant. Okay, and the rate of change will be different. What is another word for rate of change? There's one word we like using that refers to rate of change. Does anybody know what that word is in graphs? It's not variable. I'm going to give you guys a clue. It starts with a G. Anyone catching my clue right now? The rate of change of a graph. How fast is a graph changing and in which direction? It's called a gradient. Okay, in our next lesson, we'll be dealing with the gradient. I just wanted to introduce it here. Okay, so if the rate of change is different, that means you have a nonlinear graph. Okay, and the result of having a different gradient means your graph will either curve or change in direction. Keep that in mind. Okay, so it will either change direction or it will be a curve. Okay, now let's see. Are the following graphs linear or nonlinear? First one, we have a distance traveled by a car. We start off at 0 meters in 0 seconds, and we slowly, gradually increase. Is this a linear or a nonlinear graph, guys? What do we think? Alice says linear. What does everybody else think? I'm going to write the coordinates here. So the first one we know is 0, 0. Okay, the second one is 5 with 50. I'm actually not going to write the x because the x is at the bottom. So the first one is 0. Here is about 50. At 10, we have 200. At 15, we have 450. And at 20, we have 800. Okay, so what is the rule about linear graphs? They need to have a constant difference. What's the difference between this point and this point? I went from 0 to 50. So what is my difference there? This is a positive 50. Then I went from 50 to 120. So what is the difference? Now we suddenly went up by 150. And then from 200 to 450, what is my difference? 250. I hope you guys have decided your answer now. And then from 450 to 800, what is my difference? 350. Is this difference constant? There is a difference, but is it constant? No. So does that mean this is a linear or a nonlinear graph? Nonlinear. Nice. Now, I want to give a major shout out to the people who answered, even if it was wrong, because, okay, you will never know for sure if a graph is linear or nonlinear unless you check the points. Okay, we were using the same intervals over here, 0, 5, 10, 50. So we're going up in fives. Okay, so we're going up in the same intervals, yet we can see that our difference is not remaining the same. So if you are not sure, just find the points. Okay, find the points like we have, and then check from 0 to 5. Is that the same difference as if I go from 5 to 10? Is it the same as if I go from 10 to 15? That is the only for sure way that you will know whether you have a linear or a non-linear graph. All right. Let's check the next one. Cars remaining in a parking lot. So obviously, this graph is from a car dealership, right? They're selling cars. Okay. So that means when 0 cars were sold, they had 150 cars. That's what it means. Okay. So we started off with 150 cars. Now, before I continue with all the points, do you guys think this is a linear or a non-linear graph? Nice. Why do you guys say it's a linear graph? It is a very straight line. That's true. Now, for people who might not be sure, let's check. Okay. From 0 to 10, we started off with 150, and after 10 cars were sold, it looks like we're at, excuse me, 140 cars. Okay. When 20 cars were sold, it looks like we're at 130. When 30 cars were sold, we're down to 120. What is the difference between these points, guys? These all have a difference of what? It's 10. So they're going down in tens. All of them. So that means this is definitely a linear graph. Okay. Definitely a linear graph. Now, I'm glad you guys could recognize that, because usually when your difference is negative, everyone gets confused. So it doesn't matter if your difference is positive something or negative something. If it is constant, it is a linear graph. Okay. This is a similar one, but now we're measuring the cars that have been sold in 2019, the second half of 2019, right? In July, we have sold 25, and then we've sold 30 in August, and then 15 in September, 35 in October. Is this linear? No. Thank you, Sinoguhle. You have answered me. This is a non-linear. Now, I know this is a straight line, but it is not a constant straight line, because remember, definition of linear graphs. What did we say? We said it either has a constant difference, and if it doesn't, you're going to see what? Your graph is either going to be curved, or what was the second condition? Does anyone remember? Let's see who has a good memory here. No, we said if it's nonlinear, there's two ways you can know it's nonlinear. It will either be a curve, or it will do what? It will change direction. Yes, Mavis, it will change direction or gradient, okay? It was going up, and now it's going down, and now it's going back up, and now it's going down, and now it's going back up. It's changing direction too many times. It can't be a linear graph, okay? So remember, these are my two conditions. Do not think just because it's straight lines, this makes it linear. No, that doesn't make it linear. Okay. Another thing we're going to speak about on Thursday is why there is a dotted line instead of a solid straight line. I'm curious to know, does anybody know the difference? When do we use a dotted line? I mean, in this one, we use the straight line. Right? And here we use the dot. This is actually should have been a dotted line as well, but we'll talk about that later. But here we used a solid line. Does anybody know why? Curious to know if anybody knows, when do we draw a straight solid line? No. Alice tried, but that's not the reason. It's fine. Well, no. Thanks for trying, Sinoguhle and Alice, but those are not the real answers. We're going to speak about it more on Thursday, but it has to do with the type of data you have. So sometimes you have data that you measure, and sometimes you have data that you count. So just keep that in the back of your mind. Okay, here's my last one, linear, nonlinear. You don't need a graph to figure this out. You can just look at it and know if it's linear or nonlinear. Okay, let's look here. The number of packets of chips sold and the income. Okay, that is true, Mavis, but we will address it on Thursday. Okay, it is linear. And how did you know that, Sinyani? How did we know that this table represents a linear graph? There's a constant difference. And what is my difference? What am I going up by for this graph? Yes, 35. So let's go from 35 to 70. We added 35, added another 35 and another 35 and blah, 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 blah. So this constant difference means that my graph is indeed a linear graph. Great. Can I have thumbs up, thumbs down on linear and non-linear graphs? Just go to the bottom and say send a reaction and give me one of these if you understand. And one of these if you don't understand. Okay, the only thumbs down I saw was mine. I hope I didn't confuse myself. Okay, I'm going to skip right past that because we're only 20 minutes into our lesson. So let's keep going. Now we're going to speak about increasing, decreasing, and constant graphs. Now, let's look here. Okay, when the relationship between the x and the y-axis are in direct proportion, this is an increasing function. Now, to remind us what direct proportion means, I have it over here. As the x values increase, the y values will also increase. So your graph will look like so, increasing graph, okay? A decreasing graph means that the relationship between your x and y values is in indirect or inverse proportion. Okay, now to remind each other and ourselves, what is indirect proportion? As one increases, what happens to the other one? Let's hear about indirect proportion. That other will decrease. Okay, so that is indirect proportion. An example is the graph that we just had now about the number of cars in a sales lot. The more cars you sell, the less cars you have in your shop. Okay, so sales are going up, but the number of cars is going down. That's indirect proportion. And then we have finally a third type of function, which is a constant function, where either your x or your y remains the same. Okay, we'll speak about what that looks like just now. Now, let's determine whether the following are increasing, decreasing, or constant functions. We're going to start with the table because we can. Okay, let's look. First, we're going to look at our x variable, which means these values at the top of the table here, these ones. Are those values increasing or decreasing? I have a -2, -1, 0, a 1, and 2. Are they increasing or decreasing? That's true, Alice. These values on the x are increasing. All right, let's look at the ones on the y. -8, -6, -4, -2, 0. Are those values increasing or decreasing? Think of your number line in negative numbers. If I'm going that way, am I increasing or decreasing? I am indeed increasing. This means both my variables are increasing. So is this an increasing graph, a decreasing graph, or a constant function? Which one is it? This is a increasing graph. If both are increasing, then it is an increasing graph. Nice. The next one is a little bit easier to see, okay? This is about the reproduction of bacterial cells. All of you thinking of taking life sciences, this is the stuff you'll be dealing with, okay? So cells divide, okay? And as they divide, you have more and more cells, obviously, right? For instance, if you have one cell, it will divide into 2, but if another division happens, you now have 4, because this divided into 2 and that divided into 2. If it happens, you now have how many? 2, 4, 6, 8. You guys get it, right? So this is what we're talking about here. This is what this graph is showing us. Now, is this an increasing or a decreasing graph? Look at your values. Is this an increasing or a decreasing graph? Alice is increasing, okay. So does Mavis, so does Singani, and they're right, okay. Increasing and decreasing has nothing to do with whether this is a linear or a nonlinear graph. Are we listening? Those are two different properties. So they have nothing to do with one another. All right. Sinoguhle, what can you see on the screen? If you can see the chat, then you might need to minimize the chat so you can't see both at the same time. So you go to the cross on the chat and you close it, and then you'll be able to see my screen. Okay. So this is an increasing graph. Is it linear or non-linear? Let's see what we're saying. It is nonlinear. So it is a nonlinear increasing graph. This one is a linear increasing graph. Okay, don't get confused. Great, now we have two graphs here, but they represent the same type of graph. Is this an increasing, decreasing, or a constant graph? Both of these. It is a constant graph. Unfortunately, Maureen, I cannot change names from my side. You have to do that on your side. Okay. I'll find out for you how we can work with that. That is indeed a constant graph. And how do we know that? For the first one, my x value did not change. No matter where you go on this graph, even if I choose a point there, my x value will be 1 and then there'll be a y value. Okay. Even if I choose one there, my x value will still be 1 and then I'll have a y value. So this is what a constant graph looks like. Okay. I think you can change your views, Guhle. Change to what you can view. Okay. There we go. All right. And if you look at y as well, all my y values are the same, even though x is changing. So basically, a constant graph is parallel to one of the axes. This one is parallel to my y-axis. Okay, look there, look there. And this one is parallel to my x-axis. It will be a straight line forever and ever and ever. Okay, so this is indeed a constant graph. All right, can I have thumbs up, thumbs down on increasing, decreasing, and constant graphs before we move on? Alice? I'm pretty sure I just have to allow everyone to unmute. But you guys must behave. Okay, so that Alice can unmute. Oh, you can unmute, Alice. Just unmute, my darling, and ask. Hello? Oh, okay, you pressed the wrong button. Okay, sorry. All right, great, guys. Now we're going to come back to the stuff. Okay, now we are supposed to state if it's increasing, decreasing, or constant, and whether it's linear or not. Okay, let's start with linear. Is this graph that you can currently see here a linear graph or a non-linear graph? It is a non-linear. How do we know that? It's curved. It is not straight, it is curved. So this is definitely a non-linear graph. And is it increasing or decreasing? You guys are right. So this is a non-linear decreasing graph. Okay. Wonderful. Let's look at the next one. Do we have a linear graph or a non-linear graph? Do we have a linear or non-linear? Linear. And why do we say that? It's a straight line. And is it increasing or is it decreasing? It is a linear still, but it is a decreasing linear graph. Wonderful. Let's look at this last one, my table over here. Okay, my table looks, there we go. It's taking up a lot of space. Okay, now let's look. In order to determine whether it's linear or not, we need the constant difference. Well, the difference. We need to check if it's constant. Okay, so going from 125 to negative 125 to negative 25, what did I do there? You added 100. That's true. And from negative 25 to 75, we added 100 again. Then it's easy because you can see that I'm adding 100. So is this a linear or non-linear graph? It is indeed linear because we have a constant difference. Okay, now let's check if it is increasing, decreasing, or constant. What's happening with my x values? Are they increasing or decreasing? They're increasing, thank you. They're going up. And my y values, we just determined that they're also increasing. So is this a increasing, decreasing, or a constant graph? It is indeed an increasing graph. Nice, guys. Okay. Now let's look. When are the following graphs decreasing, increasing, or constant? Now this is to show you guys that it is possible for a graph to have all three properties, okay? Such as the one we can see here. This graph is representing the number of running shoes that we sold during this week, Monday to Sunday, okay? When is this graph increasing? Let's start with increasing. When is this graph increasing? Yes, the first time is from Monday to Wednesday. You can see this is an increasing graph. So we have Monday to Wednesday. Is that the only time when this graph is increasing? As well as Thursday to Friday. Guys, you can unmute. So if you have something to say, you're allowed to unmute, okay? As long as we behave. Okay. Now we have a decreasing interval. And when is this graph decreasing? Sinobuhle and Alice say? No, that was for previous one. Never mind. It is decreasing from Wednesday to Thursday. Wonderful. And when is this graph constant? Friday to Sunday. And we know it's constant because we have a straight line. Wonderful. Now I have a question. Is this a linear graph? Yes, we will, Alice. Is this a linear graph? Okay. Those who are saying no, why do you say this is not a linear graph? Give me the reason. It is a straight line, but why is it not linear? It is a non-linear. You guys are correct. This is non-linear because you need to know your reasons. Why is it not linear? That's true. The rate isn't constant because it changes direction. Right. Okay, we'll come back to Peter and his run. Let's answer these questions. Okay, so now we have a graph that speaks about the depth, which means how deep did the scuba diver go into the water. Okay, so it's talking about the depths of a scuba diver. All right, so now we're going to unpack this graph and see what it means. I'm going to use the questions to answer that. I know the depth questions are very hard for you guys to understand. It's easier when we're talking about height, right? It's easy to visualize a plane. Okay, but now I want you guys to imagine, right? This is the dude they're talking about there. Huh, right? He's about to dive in. Before he dives in, yes, before he dives in, guys, what is his depth? What is the depth of the scuba diver before he dives in? Yes, Alice. Okay, so over here and over here, where the depth is 0, that means this guy is above water. Okay, I need you guys to understand that. He didn't dive in at all, so he's above water. He's at 0. Okay, so let's get going. How long was the scuba diver under the water? Let's look at the graph. Nice, Senyane. He was under the water for 30 minutes. And we know that because at minute 30 is when he is back on the surface. So minute 0 and minute 30 is when this guy is on the surface. Right? That means he was under the water for 30 minutes. Great. What was this guy's depth after 4 minutes? It was 10 meters. Great. Okay, with such question, you need to be very careful to put your units. So to find that, we're going to go to the minutes that we're given. So after 4 minutes is over there. We go up in the graph until we touch the graph, which is over there. Then you go sideways and you check. He was 10 meters under the water after 4 minutes. All right. How long did the scuba diver spend at a depth of 30 meters? I see Senyane and Alison answers. How long did this person spend at a depth of 30 meters? So there's 30 over there. Okay. We're going sideways. We're going sideways. At minute 10, this person reached 30 meters. Are we with me? He reached 30 meters. Now, I want you guys to tell me what this flat line means over here. What does that flat line mean on the graph? What is constant? Let's speak about this specific scenario that we have here in front of us. What is constant? So he didn't move. Do you guys agree? He did not move. So at minute number 10, he arrived at the depth of 30 meters, right? And then he stayed at 30 meters until minute 16. So if he got there at minute 10 and stayed there until minute 16, how long did this person spend at the depth of 30 meters? 6 minutes. Are we all good with that one, guys? Do we all understand why it is 6 minutes? Okay, so he arrived at 30 meters at minute number 10, and he stayed there until minute 16. Then he started to resurface, and we know this because the distance between ground level and him started decreasing. That means he's getting closer and closer to the ground level. All right, guys. Great. Complete the sentence by filling in the missing words. Between minutes 0 and 10, the depth of the driver is doing what? Increasing. It's increasing, okay? It's increasing, Okay, because at minute 0, he was 0 meters below water. But at minute 2, he was already like 7 meters below water. At minute 4, he was 10 meters below water. So the depth is increasing. What's happening between minute 10 and 16? Minute 10 and 16, it is constant. The depth remains constant. And what happens after minute 16? The depth is decreasing. Nice, guys. That was a great one. Okay, can we have a thumbs up, thumbs down on this one? Wonderful. Wonderful, wonderful. Okay, I have another one, but it's much quicker and easier. So let's see. So you're boiling water at home, and then it boils at 100 degrees Celsius. And then obviously, once the kettle is switched off, what happens with the temperature? What happens after you switch off the kettle? Temperature of the water will decrease, right? Because you're no longer applying heat to it. Okay, you've stopped applying heat, so now it starts to decrease, and that's what happened over there. All right. First one says, what was the temperature of the water when you turned the kettle on? What was the temperature? You cannot assume it's 0. You must look. I'm glad that nobody said 0, because if you said 0, that means my graph should have been starting over there, right? Okay, maybe you guys can't see. Let me zoom in a bit. Is that 10 degrees Celsius? Look carefully. Try to be as accurate as possible. It's more like 15. Okay. So the temperature of this water was about 15 degrees Celsius or 17. So we usually take a range in such questions. Okay, so there won't be one correct answer. We'll take a range of answers. And then estimate the temperature of the water after 10 minutes. Where did I go now? There we go. After 10 minutes, which means over here, what is my temperature? So you guys must go to the side. My hand is not straight at all, so you guys are going to just have to bear with me here. Luckily, they said estimate, right? So it's about 88, 85, 86 degrees. I'm going to go smack in the middle and say 85 degrees Celsius. Okay. Now I have my own question here. How long did it take for this water to boil? How long did it take for this water to reach boiling point? That is true. That is 5 minutes because that is over here. All right. Nice, guys. Okay, so I'm going to go back up to those ones we said we're going to come back to. When is this increasing and when is it decreasing and when is it these guys? Okay. I want you guys to tell me if these are increasing, decreasing, or constant graphs. Let's look at number 1. What is happening there by number 1? Firstly, let's establish that our inputs are all increasing. Do we see that? Look at 1, -1, 0, 1, 2, 3, 4. This is increasing. This is increasing, increasing, increase. So we've already established that my inputs are all going to be increasing. We now have to just look at the output. Okay? So let's look at my output. How do I get from -4 to -2? I add 2. -2 to 0. I add 2, so we are adding 2. So is this an increasing, a decreasing, or a constant graph? This is an increasing graph. Wonderful. Let's look at the second one. How do I get from negative 3 to 0? I added 3 and I was about to write 5 even though I said 3. 0 to 3, I'm adding 3 again. So what type of graph do we have over here? It's an increasing graph. Wonderful. Let's look at the next one. How do I get from 3 to negative 3? 3 to negative 3, we're subtracting 6. Negative 3 to negative 9, we're subtracting 6 again. So what is going on with my graph here? What type of graph do I have? This is a decreasing graph. Decreasing. I just came up with a question now and I'm going to ask you guys at the end. Okay, let's go to the next one. 987654. That is a decreasing graph because I am subtracting 1. Okay, so then this is a decreasing graph. All right, next one is very interesting. Okay, how do I get from 1 to 0? Minus 1. How do I get from 0 to 1? Plus 1. 1 to 4. Plus 3. We're about to discover something very interesting here. 4 to 9. Plus 5. So what is going on here, guys? Why do I have different types of values here? Why can we not decide if this is increasing or decreasing? Ha! Alice. Alice, my dear, this is a non-linear graph. And what does it mean when I now had a negative, but now I'm having positives? That means it is, what's going on with my graph? Ha, it changed direction. Beautiful, Alice. This graph has changed direction. So let's establish a difference between when do we know it changed direction and when do we know that it's curved. Okay, I see well, a lot of us are saying curved, a lot of us are saying change direction. Remember, this is a change in direction. And this is curved. It didn't change direction that much, but it's curved, right? Change in direction you can tell by if your constant difference suddenly goes from plus to minus. That is your change in direction. Okay? Whereas with a curved one, they might all be positive, but what? There's a crazy difference between numbers. Nice, Alice. So if you suddenly go from positive gradient to a negative gradient, you know that you have constant difference, excuse me. Oh, I didn't mean gradient, I mean difference. So if your difference went from positive to negative, then there has been a change in direction. Okay, if my difference is the same sign, if it's the same sign, but, yeah, that B is not cooperating with me, but not constant, then it is a curved graph. All right, guys. And then the last one, let's look at the last one. Negative 1 to 0. How do I get from negative 1 to 0? I added 1. 0 to 1. I added 1 again. But 1 to 8. I added 7. Do you see why you need to check more than 2 numbers or 3 numbers? Because if I had stopped here, what were you guys going to say about this? If I didn't try another difference, what were you guys going to say about this graph? It's increasing and it's a constant difference. You guys are going to say it is linear. That's what you guys are going to say. But as soon as you check another one, you can see that, oh, nope, something is off here. Right, because then from here to here, I added 19. See, there's a lot going on here. So this might not be a linear graph, but you can still tell if it is increasing or decreasing. How can I tell? Is it increasing or decreasing? Let's hear. Is this last graph increasing or decreasing? Bigger positive numbers, so it is increasing. Nice. And just to challenge you guys a little bit, can you guys see by observation? I know we did this. Can you guys find the equations of 5 and 6 by observation? Can anyone find the equations of 5 and 6 by observation? I have a negative 1 with a 1, 0 with a 0, 1 with a 1, 2 with a 4, 3 with a 9, 4 with a 16. Something should be standing out to you. What are these numbers at the bottom? 1, 0, 4, 9, 16. Do those look familiar? Anyone? We're not seeing it. They're square numbers. They're square. So will I ever have a negative output? No. Because if you square a negative number, what happens? What happens when I square a negative number? It will make it positive. It will make it positive. Remember, negative 1, if you square the whole thing, that's a negative times a negative, which will give you a positive 1. Okay, so then the equation of number 5 is y is equal to x squared. So you take the one at the top and you square it. Negative 1 squared is 1. 0 squared is 0. And so on. What about 6? After we did that one, 6 should look a little familiar as well. Y is equal to, there we go. And this, y is equal to x cubed. Because if you cube a negative number, you're still going to get a negative number. It doesn't make a difference. Okay. Whew. I think our brains worked enough, guys. This was great.